Hello guys, we are back with our next lecture. In this lecture, let us continue with the next topic, that is a basic 2PL guys. So in the last lecture, we discussed the basics of locking guys, right? Yes. So this is a continuation, you can say. So in this lecture, we'll be discussing about a basic 2PL guys. So this 2PL also belongs to the locking concept only. Okay. So let me first explain you the exact approach. Then I will be explaining you the theory. Okay. Yes. So when it comes to a transaction, what we do here is, so we start locking things, guys. So whatever we want, we are going to lock it as we progress. Okay. So once our particular works are done, we will unlock it, right? So once you start unlocking, you will never lock anything, guys. Okay, so I understand that most of the students are not getting any particular idea with respect to it. So understand it for now. So first of all, there are two phases, guys. So the first phase is a growing phase. So in growing phase, the only one work you can do is a locking. So you can lock as many items or as much data items as you want. And once your whole locking is done, and once you start unlocking someone, you can never lock anyone, and now you are in shrinking phase. So in shrinking phase, you can only unlock everything. That's it. Got it? Yes. So I understand that only few students got some idea, but now let us go through a small example, guys. So once we start understanding the example, you will get more idea. Okay. Yes. So assume that. Okay. So assume that first we want to perform write operation on A. So recall. So if we want to perform write, which lock should I apply, guys? So I should apply only exclusive lock, right? Because there is write operation, means no one can enter inside. So that is the reason why first I am going to make exclusive lock, then I am going to read the data, then I am going to write the data. Okay, so after that I noticed that I need to perform a read operation on B. So as it is a simple read operation, I can use a shared lock. So now I locked it with shared lock. So now in total I'm having two locks. Okay, then I'm reading the value B. Okay, so now my whole work is done. So once my whole work is done, I will start unlocking it, right? So I unlocked A. So I'm unlocked the exclusive lock with respect to A. Then I committed, guys. So in simple words, once I commit all the locks, so basically here we created two locks, right? So both of those locks will be unlocked, guys. So once we commit is done, all locks are unlocked. Okay, and the point where we exactly unlocked our first lock is nothing but the lock point. Got it? Yes. And here in this whole phase, you will never find a unlock, right? Yes. So we are finding only lock. So it is a growing phase, and this is the simple phase, which is a unlocking phase. That is a shrinking phase. Got it? Yes. So now I think everyone is understanding at least some basic things, right? Yes. Okay. So now let us go through the definitions. Okay. So the protocol ensures that each transaction issue lock and unlock request into two phases for each transaction. So growing a phase only obtain locks, shrinking a phase only releases locks. Got it? Yes. So growing phase, then shrinking phase, and the exact point where it will start shrinking is nothing but the lock point. Got it? Yes. So first unlock tells us it entered to the shrinking phase, right? Then how you can, few students will be like, how we can know that it is in shrinking phase? So once you start unlocking, it is nothing but shrinking phase, guys. Got it? Yes. Okay. So now let us take some more examples. So this is a simple example, right? Yes. So observe here carefully. So is there any issue with respect to this also we'll be discussing? So please concentrate. Okay. So in this whole code, I am having two variables, A and B, guys. Okay, so first of all, I observed that I need to perform read as well as write operation on A. So now what I will do? I will make exclusive lock for T1, right? Yes. So I made exclusive lock with respect to T1 for A. Okay. So now I have started that exclusive lock and I did read operation and write operation. Okay. So after that, T2 wants to perform just a read operation on B. So now what I will do? I will give shared lock for T2. Okay, so after this, T1 wants to perform read as well as write on T1. Okay, so now if you observe here carefully, so I told you one important thing. So if you start unlocking, you can never lock again, right? Yes. So now we are indirectly stuck here, right? Because we want to perform write operation, but here it is a shared lock. So you cannot lock it, right? So you want to make, so let me take some other color. So you want to make it exclusive lock with respect to T1, but it is not possible because it is already holding by that. Similarly, on the other hand, T2 wants a shared lock on this. Okay, so T2 wants a shared lock on this, but that is also not possible because it is already exclusively locked by T1. So indirectly what it is, guys, so one is depending on the other, but other wants other thing, so that is a nothing but deadlock. So T1 is having A, T2 is having B, but T1 wants a B, T2 wants a. So indirectly it ended up being a deadlock, right? Yes, so you understood, right? So why it happened deadlock, guys? Because one of you might be, why to go for deadlock? Unlock S here, unlock S of B, and unlock X of A, right? Yes. So most of the students will be thinking of this, but if you do that, can you lock again, guys? The answer is no, right? Because I clearly told that once you start unlocking, you should only unlock. There is no chance of locking. So at that time, this particular thing, these two steps are not possible indirectly, right? Yes. So with that understanding, we can conclude that this is a proper deadlock condition, right? Yes. Okay. So in the same way, this is one more example for dirty read, guys. Okay. So here there are two variables, A and X. Okay. So here we started with the T1 and we locked it with the exclusive lock with respect to A. We read it, we written on it, we unlocked it. Okay. So after that, assume that there is no lock here because we cannot apply lock, right? So after that, okay, so we wrote the data and we are going to read the data. So this is a nothing but a dirty read, right? Or you can write this unlock below also. So anything will work, guys, okay? Or you can strike off this unlock, that will be better, right? Yes. So let this shared lock be here, okay? Yes. So this is a nothing but a dirty read, right? Yes. So even dirty read is also possible in this basic 2PL. Okay. So now what are the whole conclusions, guys? So the conclusion is it is a conflict serializable, it is view serializable, but it is not cascadable and not recoverable because of this dirty read. Similarly, there is a chance of deadlock also. It is not deadlock free. Got it? Yes. So this is all about traditional or basic 2PL, guys. Okay. Yes. So few of the students will be like, what is this 2PL? So you are saying 2PL, 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 but you never told it. 2PL is a nothing but a two-phase locking. So what are those two phases? Lock and unlock. That's it. Got it? Or you can also remember in that way also. It is a shared lock, exclusive lock, right? Yes. So now I hope everyone got a clear idea with respect to this basic 2PL, right? Yes. So a small modification to this basic 2PL is a nothing but a conservative 2PL, guys. Okay. Yes. So in the next lecture, let us discuss about conservative 2PL. Okay. Yes. So let us meet in the next lecture, and all these algorithms will try to remove this no's, guys. So here we are having 2 S's and 3 no's, right? So this conservative 2PL will try to remove this deadlock issue. It wants to make it a deadlock free. Got it? Yes. So that is the goal here. Like step by step we are going to upgrade them. Okay. Yes. So now I hope everyone got a clear idea with respect to basic 2PL. So in the next lecture, let us discuss about a conservative 2PL. Okay. Yes. So let us meet in the next lecture. Thank you. Thanks for watching. Like, share and subscribe for more awesome videos like this. Thank you.